Hello, viewers. Welcome to yet another lesson here at Physuss Preme. So today we are going to look at a very interesting topic. Can you give a guess? Yeah. Today we are going to look at floating and sinking. Floating and sinking. And I want you to floating and sinking is probably a term you've heard growing up and such. It's probably a term you've heard often in layman's tongue, floating and sinking. So I want you to just think of the first thing that comes in your head when you think about floating and sinking. So when you have that in mind, we are just going to try to define it. I define floating as a state more. I think it's more understandable as a state, so that we are going to continue defining it even as we continue to learn new principles in this topic. We are going to have a by the end of this lesson, I'm hoping we are going to have a great definition of floating according to your own term. So I define floating as a state when an object floats when it is less dense than the fluid in which it is submerged in. I'm sorry for the noise in the background. I hope you can hear me through. I'm saying floating, an object floats when it is less dense than the fluid in which it is submerged in. Okay. I hope that is quite understandable. As we are continuing more and more and more, we are going to derive more formulas. You're going to explain floating in a more scientific view. So let's continue. For now, I hope that is understandable to everyone. Okay. So sinking, an object sinks when it is more dense than the fluid in which it is submerged in. Another thing I want you to take note of is the fact that I'm using fluid to describe the thing in which an object is put in. Fluid, because an object can float in gas. An object can not only float in water, it can also float in other types of liquid. The term fluid is basically, scientifically, the term fluid can be used to generalize both gases and liquids. That's why I'm using the term fluid. An object can float even on air, like the balloons. The balloons float on air. That is also explained in this topic of floating and sinking. You'll understand that not all balloons can float on all types of air. It also depends on the air around. It also depends on the air around. Like you cannot have a balloon which is filled with oxygen to float in a to float in a in a in a in a medium, or to float in an environment which is filled with helium, because helium is less dense than oxygen. Oxygen is more dense. So oxygen cannot float at that point. Oxygen cannot float in a medium or an environment which has helium. You get? Yeah. Sinking, that's why I'm using the term fluid to express it. Okay, so sinking, we said it's an object sinks when it is more dense than the fluid in which it is submerged in. I was just trying to explain floating and sinking as the aspect of our day-to-day views. Even balloons, they use that term, floating and sinking. Not only you can throw coins in water, we are going to also explain how that works, how it sinks, how a bottle top floats. We are going to have all that explained in this topic. So you're noticing in my definition, both in floating and sinking, I have introduced a very, very, very important mathematical term, which is density. More dense. Here we have more dense. In floating, we have less dense. We have that term, density. As we are, understanding physics, you need to break down these simple mathematical terms that are being introduced in definition for you to come up with now formulas. So we are going slow by slow, slow by slow, slow by slow. Density. Less dense, sinking, more dense. Okay. Now take note that density is equals to mass or volume. As you are continuing, this will be important to take note. So I'm just asking you now to take note that density is equal to mass per unit volume. Okay. So moving on, we are going to introduce a very important principle that enables us understand floating and sinking in a very deeper deeper level. And this is actually the Archimedes principle. What does the Archimedes principle state? Archimedes principle, it states that a body submerged in a fluid experiences an upthrust force equal to the weight of fluid it displaces. And again, you're noting I'm using fluid. Most people, when it will come to expressing these principles, they will forget to use fluid. They will focus on just water. I don't know, it's common for many learners to just focus on water, but I want you to see it normal as fluid, so that even when you see air, when you see other types of fluid like mercury, you are not confused. You also know that floating and sinking takes place in them. So that in at the exam or when being tested, you don't only wait to see the word water so that you know they're testing about floating and sinking. When you also see balloons, when you also see air, when you also see kites, you will know they're also testing. They're also testing floating and sinking. They also may be testing floating and sinking. I want you to get used to that term fluid. So Archimedes principle. We have said Archimedes principle states that a body submerged in a fluid experiences an upthrust force equal to the weight of fluid it displaces. I hope that is clear. So physics, I said in physics we should learn whenever we introduce any mathematical term or any scientific term, we should learn to break it down to mathematical concept such as formula, so that it's easy for us to now solve problems in our day-to-day life. Eh? Are you understanding? So we are going to break down this Archimedes principle mathematically. We have said Archimedes principle: a body submerged in a fluid experiences an upthrust force equal to the weight of the fluid it displaces. Now, here is our breakdown. Mathematical expression of Archimedes principle. We have said the weight of for a body that is submerged in a fluid, for a body that is submerged in a fluid. Again, we are not talking about solids here. You cannot put a bottle top in on top of a stone and determine if it's floating and sinking. No, this only applies to fluid. So weight of the fluid displaced is equal, okay, weight of the fluid displaced, we have said, is equal to an upthrust force. Now we want to understand this better. Weight of fluid displaced generally is equals to that mass of the fluid that is displaced multiplied by g, which g is constant. G, the gravitational constant. It's constant. We already know that is 10. 10. We already know that is 10. So from that breakdown, we don't, most times you won't find mass. So we are going now to break down what mass is. Mass, we already know mass is usually volume multiplied by density. And this symbol that looks here like a P is not a P. I want to enable people understand. This symbol that looks like a P is actually rho. It's used scientifically to represent density, to represent density constants. It's called rho, RHO. It's used to represent density constants. I'm sure most of us have seen it. Rho, it's not P, it's rho. Okay, so you have said mass is equals to volume times rho. So now our upthrust force should be equal to the weight of fluid displaced. What is the weight of fluid displaced? Now upthrust force is equals to the weight of fluid displaced, which is mass times g. What is mass times g? Volume times rho. Volume times density. Volume times density times g. This is mass, and then now we times it by g to get the weight of fluid displaced. So the mathematical expression of Archimedes principle, if you're asked now to express it mathematically, or if you want to solve no problems, you're going to say Laplace force is equals to volume times density of fluid. And mark you, this volume and density we are talking about, please, students, I don't want you to confuse it. We are talking about the volume that is displaced when this body is submerged, the volume that will be of fluid that will be displaced. And the density that we are using is not of the object being submerged, but of the fluid medium in which the object is submerged in. The fluid. We are going to work with the fluid. Here, this part, everything, just focus on the fluid. Don't even focus on the weight of the object or anything. This, all of it is fluid. The weight of fluid displaced. So, take note. Please, again, take note. Don't come and put density constants of the object. Put density constant of the fluid and volume of the fluid. G is less constant. So now we have upthrust force is equals to volume of the fluid displaced times density of the fluid displaced times G. Now we are going to also understand that this Archimedes principle is going to enable us explain upthrust force, or going to enable us explain floating and sinking in a more understandable manner, in a more scientific manner. Yeah, I hope we are together. We are together in this. We're going on together. Now we are going to explain floating and sinking using the Archimedes principle. In this case, you're going to use a specific scenario. A specific scenario. We have already said that weight is equals to the volume of the fluid displaced times density of the fluid displaced times G, which G is constant. Again, take note, this P is not P, it's rho. This P you're seeing is not P, it's rho. It's rho. Rho is a symbol. Again, I said rho is a symbol that scientifically is used to represent density constants. So, in this scenario, we are using, let's say the density of the fluid is less than the density of the object. This is the scenario we are using. When the density of the fluid is less than the density of the object. First, from our definition of floating and sinking, we say that a body will float if it is less dense than the fluid in which it is immersed in, and a body will sink if it's more dense than the fluid in which it is immersed in. So in this case, the object now has a higher density, so it will sink from that definition. But now here we are going to use Archimedes principle to explain why it will sink. Okay, when the density of the fluid is less than the density of the object, the weight of the fluid displaced will be less than the weight of the object. Do you know what this means? The weight of the fluid displaced. Why? This, I want you to be very keen as I'm going to explain this. When the volume of the body, we both know fluids have a definite, fluid have definite volume. But here, when the weight of the fluid displaced, okay, sorry for the short break. Now I was explaining that in this scenario we are going to use is when the density of the fluid is less than the density of the object. So density is directly proportional to weight. Density is directly proportional to weight. So when the density of the fluid is less than the density of the object, the weight of the fluid displaced will be less than the weight of the object. Hence, upthrust force, now weight of fluid displaced is same as upthrust force. That's why we have introduced upthrust force here. Hence, upthrust force is less than the weight of the object. Let's see it as a downward force because it is acting downwards. Is less than the downward force. The which is the weight of the object. Now, I hope all of us are familiar with the third law of Newton that states that for every action there is a reaction. For every action force there is a reaction. So in this case now, the downward force which is acting, it's the action. The downward force which now is the weight of the object, it's working downwards, is greater than the upthrust force which is lifting it to remain, to enable the it's greater than, we find the downward force is greater than the upthrust force which is working against it to try and make the body float. At this case, when the downward force now, which is the weight of the object, is greater, it will overcome or it will overpower this upthrust force, causing this object to sink. So the resultant force will be downwards and the object will sink. The resultant force will be downwards and the object will sink. Then I've stated the third law of Newton there for everyone who has forgotten. For every action, which is the weight of the object, there is a reaction, which is the upthrust force. The resultant will be positive. It will still go down. It will still be acting. Action now is positive. Action is the weight of the object. It is positive. It is going down. If it will be negative, if it will be upthrust, it will mean upthrust is more. If the resultant will be negative, it means upthrust will be more and the body will be floating. But in this case, the resultant is positive and the body will sink. Therefore, the definition of floating and sinking is derived. Again, this is now explaining sinking. Now let's try to explain floating. If you're told in a test or you're being tested to explain sinking using Archimedes principle, you start explaining the same way but vice versa. Now, when the density of the fluid is greater than the density of the object, the weight of the fluid displaced at that point now will be greater than the weight of the object. Hence, the upthrust force will be greater than the downward force, which is the weight of the object. The resultant force will be upwards and the object will float. The third law of Newton states that for every action which is the weight of the object, you need now to explain what is the action at that point, which is the weight of the object. There is a reaction which is upthrust force. The resultant at that point will be negative, hence the object will float. Therefore, the definition of floating. We have explained sinking, we have explained floating. I hope we have understood. But if you feel you have not understood a specific aspect there or it's difficult, you can just comment on down there and I will try and help you understand more. Now, moving on. Again, sorry, there's a special thing, an important thing I forgot to mention. In floating and sinking, take note. In floating and sinking, or using the Archimedes principle, we do not use objects that absorb fluid. Example, cotton. Example, or have air spaces between them to absorb fluid. Example, cotton. Example, cotton. Example, sponge. Sponge is a good example. Example, clothes which are made from cotton, or clothes. Because you know why? It will temper. The it will temper with the weight of the object first, which is sinking, because as it absorbs more fluid it becomes more heavy. So it does not apply there. It will temper with the weight acting downwards. So we can't use that here to explain this. We can't use it. Factors influencing floating and sinking. Factors influencing floating and sinking. Factor number one, a very important factor which we even used in our in defining floating and sinking, and this factor is density. Density. If the object is less dense than the fluid in which it is submerged in, it will float, and vice versa. This one, if you are told now to explain it, you can use the Archimedes principle to explain. Maybe in a test you are asked, explain how density affects floating and sinking. You can say, you can explain using the Archimedes principle. You can go through what you have learned from the Archimedes principle and then come about with, therefore, this means that if the object is less dense than the fluid in which it is submerged in, it will float, and vice versa. I hope this is very simple to explain it with Archimedes principle. Once again, let me just repeat it for the people who didn't understand. In the Archimedes principle, if the weight of the fluid is less than the weight of the object, let's begin with density. If the density of the fluid, here we are saying density of the object. If the density of the object now, of the object, is less than the density of the fluid, the weight of the object will be less than the weight of the fluid. So the weight of the object, so the upthrust force, which is the weight of the fluid displaced, will overpower the weight acting downwards, which is the weight of the object, hence keeping the object afloat. Hence, the object will float using the third law of Newton. Hope that is understandable. You can go back again to Archimedes principle if you don't still understand it. Yeah, just a minute for you to try and grasp it. You can pause. So we continue. Second factor affecting floating and sinking, a very important factor, is relative density. Relative. The term relative, when you see relative, it means basically to relate. And for you to relate, you need to have two people. Example, when you're saying I'm related to, they need to be two people. Like you're comparing how you are related. So relative density basis, it's also comparing. You have two things, two densities you're comparing. Relative density, two densities you're comparing. If you say you are relative sisters, you are two sisters we're comparing. Relative density, it is two densities we are comparing. So relative density is density of an object over the density of fluid, or density of object to density of fluid. Basically division. Density of object to density of fluid. So we say that if the density of an object is more dense, the body will sink. If the density of an object is more dense than, if an object is more dense than the fluid in which it is submerged in, it will sink. And if the density of the object is less than the density of the fluid in which it is submerged in, it will float. So now if you divide them and you get that the relative density is less than 1, it means the object floats. And if the relative density is greater than 1, the object sinks. This just says, if you see them, if you see them when you're looking at them and you just see, obviously when the density of object is higher than the density of of fluid, it will give you a improper fraction. An improper fraction is, it means it's greater than 1. That means it is sinking. If now the density of object is less than the density of fluid, it will give you a proper fraction. A proper fraction means it is less than 1. That means it is floating. Very simple. Proper fraction, floating. Improper, sinking. If you don't know that, you can also say less than 1, floating. Greater than 1, sinking. Hope that is easy. We've all understood. Factor number 3 is density of the fluid. So that's it's just like the density of the object. That factor number 1. Actually, our first factor, we would have labeled it as density of object. So we have density of object, we have relative density, we have density of fluid. And the relative density is basically comparing relative density is basically comparing density of object to the density of the fluid. Now, density of fluid, it is just vice versa of this thing. Number 1. So you say that if the density of the fluid is greater, if the density of the fluid is greater than the density of if the density of fluid is greater than the density of object, the object will float. If the density of fluid is less than the density of object, the object will sink. Here we have rho. This is rho. This that looks like 8 alpha, alpha sign is used to as a proportionate sign in science or in physics or in maths. So you say the density of a fluid is directly proportional to upthrust, meaning the higher the density of the fluid, the more the object is likely to float and vice versa. Here we are basically seeing that upthrust force is the one assisting a body to float. Upthrust force is a very, very important force in explaining floating and sinking. So density of a fluid is directly proportional to upthrust. The higher the density of the fluid, the more the object is likely to float. So that can help you even when solving real to real terms. If you're making a project, maybe you want your object to remain float, you need to find a liquid that is very, very dense to ensure that whatever object you're using above, even if it's heavy, it does not sink. But ensure no, it does not, the density of that object you'll be using does not also surpass the density of the fluid. So we are going to move to the next factor, influencing. No, before weight and volume, actually. Before weight and volume, we have an important factor. And this is shape and design. Sorry, I think the notes just vanished. Before After density and fluid, we have an important factor, which is shape and design. So I'll explain it. I will put the notes in the description box. You can go and learn more about how shape and design affects floating and sinking, but I'll just explain it here if you're able to understand. So if okay, for the object now, we already know pressure is usually equal to force over area, or force per area, per unit area. So this means that pressure is indirectly proportional to the area. Pressure is indirectly proportional to the area. So this means that the more the area, the more the surface, and by area we are defining the surface area, the more the surface area, the lesser the pressure acting on it. Now we know pressure is directly proportional to force. Again, this we have derived from the same, the same formula that says pressure is equals to force per area. From it we derive that pressure is directly proportional to force. So now this means that the lesser the pressure, the lesser the force. We are saying that pressure is indirectly proportional to surface area, meaning the more the area, the lesser the pressure. And pressure is directly proportional to the force, meaning the lesser the pressure, the lesser the force. Now, according to the third law of Newton, again about competing action and reaction competing. The downward force now, when the area is more, when the area is more, we are using this scenario. When the surface area is larger, when the surface area is larger or is more, then the pressure would be less. And because the pressure would be less, the force would be less. Now, in the third law of Newton, now when you have explained it, I've already explained the third law of Newton. So the downward force competing against the upthrust in this scenario would be less, reducing the resultant force to negation, meaning the resultant force will be negative. When the resultant force is negative, meaning the upthrust force is more, meaning the body is likely to stay afloat. Why am I using the term likely and not the body will stay afloat? Because we don't know other aspects that will also at this case we don't know the other aspects such as density of the fluid and such and such, but just basing on the surface area alone, the body is likely to stay afloat because the body has large surface area. So large surface area can help the body stay afloat since it also displaces more water. It also displaces more water. Large surface area meaning large surface area is directly proportional to volume. So large surface area meaning high volume. High volume, high water displaced. High water displaced, that is upthrust force. Basically, it will be more likely to stay afloat. I will put this in the description box so that you understand how shape and design affects it. Shape and design now is our fourth factor affecting. Our fifth factor is weight and volume. Heavier objects can still stay afloat if they displace enough fluid when they are shaped to occupy a large volume. So we are saying that heavier objects can still float if they displace enough fluid when they are shaped to occupy a large volume. Just the way we said about surface area, when the surface area is large, now when the body is made to occupy a large volume, just as the way I will give an example of the way boats are shaped. You can find a boat inside, it does not have space, it does not have things in between, but they have just used a big space so that it occupies a large space for no reason, but actually there is a reason, and that reason is for it to displace more water. When it displaces more water, that means there is more upthrust force. When it displaces more water, that means there is more upthrust force. So heavier objects can still float if they displace enough fluid when they are shaped to occupy a large volume. Example boats. So application, I'll explain this application. Ship and boats, I said the way ship and boats are made. They are not made to be compact. They're actually made, they're very streamlined and very yeah, they are not made to be compact. By compact I mean it's not together. Yeah, many, when an object is more compact, it means also the density is increasing. The density is more. Also, when an object is more compact, it will also mean the volume it will occupy will be less. Compact basically mean it's compressed. I will use compressed. Ships and boats, actually, when you observe them, they occupy a large space. They are not compact. They occupy a large space, a large surface area. For them to displace more water, they are not compact. For them to displace more water, find that inside of a ship is very, or a boat is very empty. eh? Just it has just a lot of space, a lot of surface area. Yeah. Submarines have tanks, have tanks that when if the submarine wants to sink more, they open the tank so that water enters in. You know, water is more denser than air. So when water occupies it, the density increases. And you say when the density of an object increases, it causes the body to sink more. When it wants to go back up, it dispenses out the air. And it dispenses out the water so that it only remains with air. And then that makes it less dense. When it is less dense now, it floats, it goes up slowly. So depending on the level where a submarine wants to go, it can dispense out water, or if it wants to sink more, to go down more. You know, people who go and observe or experience the sea inside, they love going deep, so it allows in more water for them so that they sink. Yeah, so that's how it now regulates going up and down. When it goes down, you say it allows in more water, becomes more dense, goes down. When it wants to go up, it dispenses out water, it becomes less dense, it floats. Life jackets are the same. Life jackets are made from less dense material, more so air spaces, or very, very, very less dense materials. These less dense materials enable it to stay afloat. So that's how it helps a person to come back up. It is built by less dense materials. So the less dense material have it being acted by a larger upthrust force. So it stays afloat. That's how they enable a person to stay afloat really. Okay, hope you enjoyed this lesson. I said the notes about shape and design, I'm going to add them. If you have any question, please be free to reach out directly to me on my page. I have linked my email to my page. And if you have any question, again, you can also ask in the comments. I hope you enjoyed this video. Please don't forget to like. You can like this video if it was a help for you to you. I hope it was a really great help to you. And also comment if you have any question. If you also enjoyed this content, comment. If you want me to look at another topic next time, comment the topic you'd like me to look at, and subscribe to this channel to get more and more new topics I'll be posting. Thanks for watching. Hope you found this helpful. Bye bye.